Hey kids, here we go with our last lesson of the unit. Of course, we're going to keep on building on this in the future. We're going to have a break after this one, just to let this kind of soak in. So hang with me for one more lesson. This is actually an application of the previous lesson. Previously, we identified which equations were one, none, and infinite solutions. This time, we are going to give examples of those. So it's basically the opposite. Before we identified, now we are going to write them, I guess for someone else to identify which is which. So as a warm-up to this, I would like for you to please work out these three equations to determine which one is a one solution, which one is a no solution, which one is an infinite solution. So I'd like for you to please pause this, try it out. Don't just wait for me to give you answers, because you don't learn that way. Okay, so I'm going to assume that you have done these. So hopefully you did distributive property here. There's like three terms on each side, so I need to do some combining. Equals 13 minus 2 is 11. Ooh, plus 6x. Well, you might see 6x plus 11, 11 plus 6x, that's the same thing. This is an infinite solution. And you could work it all the way down so that x equals x, but you don't need to if you can determine that it early and if you, don't care to do all the extra work. All right, here we have two terms and two terms. I'm going to start by getting rid of some negativity. Still got that negative 4x though, or negative 4. All right. Now remember, I have to move the positive 10 instead of the negative 4. If I clear out that negative 4, it's going to be broken. Negative or positive is a negative. 2. All right, I got an answer. What does that mean? Yeah, it's a one solution. A negative 2 is the only number that I can sub in there and have it balance out. Well, that means this last one should be a no solution. Let's see if that's the case, because I see 2's and 5's. Maybe it's going to be another infinite solution. So here I have 2x. Ah, there it is, 10. 2x and 10, 2x and 5. It's going to come out with 10 is 5. Is that possible? 10 is not 5. A $10 bill is different than a $5 bill. This is a no solution. No single number can be substituted in for x and have the two sides balance out. Great. Okay, so now we are going to flip this on its head. So now we have some, we're going to kind of do a moderately difficult phase here, and then we'll throw you in the deep end. So here we go. We're going to fill in these blanks so that the equations have infinite solutions. These. Okay. And the characteristic for that is that they are the same on each side. Well, remember, when you have the distributive property, 6x plus 12, so that means on the other side, I also need 6x plus 12. There's the plus 12. What needs to go in that blank? 6x. Great job. Let's try another one. On this side, there's my 4x's again, right? Plus what? 12. Good. All right, let's try another one. How many x's? 3 times 2 is 6. I need 6 x's over here, but wait. I already have 4. So 4 and 2 more x's makes 6 x's. And 3 times 5 is 15. Great job. So it seems like for a lot of these, I have an expression with a distributive property on one side, and then that expression, it's equivalent on the right. It seems like a good strategy if I needed to write one. Okay. All right, so my strategy is I simplify. And make equation the same on both sides. So it's noteworthy here that this is same number of variables. For example, 6x and 6x, and the same number of constants, like 12 and 12. Great. Let's try another. Let's do some no solutions. Fill in the blank so that the equation has no solutions. Well, what was the characteristic of these all the way through? Seems like I keep having the same number of variables with a different constant because those variables cancel out, right? Okay, so 18x minus 9 is, well, we need to cancel out those 18x's, so there. Because when I go to take this out and that out, I'm going to get negative 9 equals nothing. So yeah, I just broke that equation. Good job. All right, here I have negative 21 x's. Negative 21 x's plus 3. Yeah, 3 is not the same as 8. When I add 21 x's to each side, they'll cancel out and I'll be down to 3 equals 8, which isn't true. Let's try another one. So I need 2 x's on each side. 2 minus 5x is how many? Negative 3x. Right. So negative 3 on this side. Be careful. This one already has an x for you, right? That one didn't. So you have to be careful to write the right thing. And this one has a negative 1 and a 5. Those aren't equal, right? Okay. We joked about these being dead birds. If I have 3 dead birds and I lost $1, that's not the same as having 3 dead birds and having found $5 if the constants are money. Anyway, that was a lot funnier in class, but just thought it'd be funny. Okay, so again, we're going to simplify and then making. Sorry. Different constants. So if we were going to boil it down to 4 words again, let's see. The variables are what? Same or different? Yeah, same variables. What about the constants? The constants are different. Great. All right, let's talk about the last one. These are going to be our regular equations, our one solutions. And we are going to specify that x equals 5. So you can't put any old number in there. We want x to be 5. So remember, we need to have the same value on each side. So if I have 13 5s, 13 times 5, what's that worth? 65. Okay. So 65 plus what is 66? 1. That's all you have to do. No biggie. Let's try another one. I have 3 times something is 6. Well, 3 times what is 6? 2. So we need this to come out to be 2. Well, 5, right, goes in for x. 5 minus 1 is 5 minus what is 2? 3. Good job. 5 minus 3 is 2 times 3 is 6. Nice. It's that easy, right? Let's try the other one. There's 2 x's, or 2 5s, that's 10. 10 and 1 make 11. What number minus 4 is 11? 15. 15 minus 4 is 11, so now they're balanced out. Great job. All right, so for this one, we simplified. Substitute x for the variable, or the solution for the variable. Then we kind of used logic to work backwards, right? To balance the equation. Great. Now you'll notice if you look across here that for each of our equations here, we had 13 and 1, 66. Those are all different. 3x, this would be 3x, and 9. These are all different. 2, 1, and 4, and 15. These are all different. So it seems that the variables are different. And what else is different? Yeah, the constants as well. Okay. Sometimes those little four-word phrases really help people a lot. Okay, so now we are going to write some samples of our own. This is the fun part for you creative people. So we're going to start with infinite solutions. Remember, those are the same variables and the same constants. Oftentimes there's distributive property on the left. Okay, we can do that. Let's just pick some numbers. 5. X plus 3, why not? On the other side, I need to have the same value. So 5 times x is 5x. 5 times 3 is 15. Now could I be creative maybe and do 5x plus 3 equals 2x plus 3x plus 15. Can you break it down like that? Yeah, sure thing. Go for it. If you want to be creative. All right, no solutions are no solutions. Same number of variables, but different constants. Okay, so how many variables do you want? 10? Now this is balanced. But if I do a 6 here and a 3 here, it's not balanced. So this would be a no solution. And again, you could break it down. Ooh, on this side you could do 2 times 5x plus 3 equals 10x. Let's do plus 6 minus 3. Haha. So they'd have to do distributive property, and they'd have to, combine like terms there. This is the sort of thing math teachers get to do when we're writing our assignments for you. And for one solution, you have different number of variables and different constants. Well, that's easy. 7 x's, 8, 9 x's, and 10. Let's do an addition and subtraction just for fun. Okay, now this is going to work out to a solution, but it could get messy. I just made this up in the moment, so this might be ugly. Minus 7, 9x. So I got negative 7x equals negative 18. Yeah, it's going to get ugly. That's okay. X equals, a negative over a negative is a positive. 7 goes into 18 twice. With 4 left over, 4/7. Okay. And that's okay. Doesn't have to be perfect. Great. Well, I hope that helped you. Let's look at your homework. Okay, and if you look at your homework, one thing that I did for you was I lined up the homework with the notes. So after the warm-up, if you line things up, they should each go together. All right, it's kind of hard to show in the video, but I think you catch my drift. Okay, and so in this first section, we got infinite solutions. So this is same variables, same constants. No solution, or same variables, different constants. And this time, one solution, so that the variable is 3. All right, and when you go to write them, remember for your one solution, you can have different variables and different constants, right? Hopefully that little help will help you, okay? All right, if you are still confused, happy to help. Shoot me an email, and I'm happy to help you. Otherwise, I will see you in class. Thanks, guys. Bye.